So we shall continue the further instruction set. Now I hope that everybody of you must have got a clear idea about the architecture of 885, that is the internal register set and ALU, its external interface with memory, and then the types of instructions, data transfer, data processing, and then control transfer. So we had gone through one more thing which I would like to tell, की instruction set मध्ये सुद्धा आपण असं नाही करत पुस्तकात दिले ओळीने इन्स्ट्रक्शन घ्या. साधारणतः तुम्हाला बऱ्यापैकी प्रोग्रामिंगचा अंदाज यावा याच्याकरता काही डेटा ट्रान्सफर, काही समजा नुसतं वर्गात असं आहे पुस्तकातले डेटा ट्रान्सफर सगळे डेटा ट्रान्सफर घ्यायचे. घेऊन करायचं काय ते प्रोग्रामिंगला काहीतरी अरिथमेटिक लॉजिक इन्स्ट्रुमेंट ॲड लक्षात आलं का. म्हणजे जास्त लवकरात लवकर वेळात हॅव यू डन प्रोग्रामिंग प्रॅक्टिस केलं का. So at the earliest you should be able to do substantial programming. So we are sequencing the instructions from that point of view. पुन्हा मग सिलेबस वेगळा असतं काहीतरी एक डोक्यात एक सांगतो आता हे इतकं सोपं आहे की ह्यामध्ये काय होईल अशा कुठल्याही भीतीच्या ह्यात राहायची तुम्हाला गरज नाही. आणि सगळे सब्जेक्ट म्हणजे थोडेसे टफ आहेत असणार नाही. कम्प्युटर सायन्स इज अन ॲडव्हान्स ब्रँच अँड since you have come out of pandemic now, there would be some kind of stress that is inevitable, and you should be able to withstand that situation because it's an engineering college and that way the system is too friendly. When you pass out and join the actual career, the system is not that friendly. So you should not be having any kind of nonsense worries like, again I repeat, notes and question paper pattern. Don't think about that. Just think whether you learn what is told in the class or not, whether you are able to use it in the lab or not. That is enough. लक्षात आलं का. So now we go for the first group of arithmetic instruction, that is add. The instruction is add. Now the second module, what is that? Different. What is the second module? Few of you who are very much fond of such, what we can say, procedural things must have seen that. What is the second module? It is number representation, not number system, number representation. Signed, unsigned, integer, floating, etc. So if we just, what happens? If we just study that, it does not have an immediate application. So what we find is that it becomes somewhat boring. So we are not going into that. So right now, hex number system or not hex, even hex, binary number system, hexadecimal is just the alternative representation of binary, wherein you group 4 bits together and represent them by a common symbol. That's all. So we have binary only. With this then, we go for an add instruction. Add instruction. So what are the in the first year you must be knowing half adder, full adder. So now in 2 weeks back when we discussed, I had presumed many things, but now I presume that nothing is prerequisite. So we start from the fundamental of addition. So binary addition. We go for binary addition. So in its common sense, if I add 0 plus 0, answer will be 0, right? It is so obvious that it need not be taught. 0 plus 1, 1. Addition is commutative. म्हणजे काय? Even if multiplication and addition are commutative, whereas subtraction and division are non-commutative, right? So 0 plus 1 is 1. 1 plus 0 is also 1. Now 1 plus 1 what happens? That's 0 and then it is a 2-bit number. So 1 0. Is it clear? So I think that now 0 plus 0 0, 0 plus 1 1, 1 plus 0 1 and 1 plus 1 1 0. Is it clear? So this is known to everybody. Like that we go by a multiple bit number. So 1 bit number, only two combinations, 0 and 1. 2 bit number, what are they? 0 0 0 1 1 0 1 1. So in that you can add 2 bit number, you can add two 2 bit numbers. What will be getting? 1 1 plus 1 1, 1 1 plus 1 1 will be what? 1 1 plus 1 1 will be 1 1 0. 1 1 0, right? समोर एकदा सोडून दाखवतो गंदे म्हणा नको. 1 1 plus 1 1 0 carry 1. 1 plus 1 0, this 1 and this carry 1. Is it right? Is it okay? So in general, addition of two n bit numbers is n plus 1 bit number. So the number which you can represent using 8 bits is 0 0 to FF. So FF plus FF is 1 FE. Now signed, unsigned, all these issues I am differing. Otherwise what happens? It means it unnecessarily takes time and does not have an immediate meaningful meaning. It has got meaning, but any immediate significant meaning. So I am unfolding it in a entirely different sequence decided by me, with your understanding and ability to program in laboratory being the focal point. So addition of two 8-bit numbers is a 9-bit number. Addition of two 8-bit numbers is a 9-bit number. Then if you want to design the instruction set of 8085, in that we have to provide one add instruction. So add instruction will require what? Add 8085 मध्ये आपला add instruction provide करायचे. 8085 is an 8-bit processor. Means why 8-bit? Because its data bus is 8-bit wide, its registers are 8-bit wide. Everything is normally 8-bit, corresponding to 8-bit. There are few exceptional instructions which allow 16-bit operation, but otherwise normally it's an 8-bit processor. So we have to design the means instruction set is prepared when somebody like you was thinking on developing it. What instructions I will provide, out of which now, in fact, few of you can start designing a new processor. I hope that time will not permit anybody. So we study the म्हणजे आपण इन्स्टंट डिझाईनच्या डोक्यात घ्यायला नको, जे आहे ते आपण अभ्यास करूया, तेवढं खूप झालं. सो ॲड इन्स्ट्रक्शन इज टू बी प्रिपेअर्ड. सो what is needed for add instruction? For add instruction, it should permit, it should allow, it should facilitate, it should provide scope for adding two 8-bit numbers. मग काय काय लागेल त्याला? It will require two operands, because addition is of two numbers, two 8-bit numbers. So source for data transfer, what we have? One to go to other. So source 1, source 2. But for addition now, we can't say source, operand 1 and operand 2, and it should be stored somewhere. Is it clear? So addition should be up. So that way we can call it a source also. Is it right? So source 1 operand means there should be, म्हणजे कुठं तरी, म्हणजे कशाची ॲडिशन करायची आहे. आपण शाळेत शिकतो तेव्हा नंबर्स दिलेले असतात, पण म्हणजे तुम्ही प्रश्न विचारला की ॲडिशन करायची, नंबरांची असते ॲडिशन. बट वेन वी थिंक दॅट इज नॉट द क्वेश्चन फॉर अस, बिकॉज वी आर ह्युमन बीइंग्स, अँड when human is to be trained, many things are assumed which everybody knows, but it's a machine. So when we think of implementing something in machine, we must provide for addition of what? Means two 8-bit numbers should be somewhere. So you need to specify where they are. So source 1 and source 2 should be specified. and their addition should be stored somewhere. Are you getting me? Two source numbers are stored somewhere, from there they are to be taken, and their additions to be stored again somewhere. So we need source 1, source 2 and destination. But there is a problem. Why? Source operand is of how many bit? 8 bit. But the result is 9 bit. So destination has to be 9 bit destination. Therefore, what 80, remember that I again repeat all the time to just give an impression that we are studying something too old. So we must be quite fast. It's 1970s processor. So that time there were design constraints. There were design constraints in designing the hardware and the instruction set design also, so because it could not handle complicated instruction set was to make smaller, compact. Only one byte was provided as opcode. Otherwise, things would have been much bigger, and it was difficult to implement. So what they have done, they have not provided enough. Listen very carefully. They have not provided enough flexibility for add instruction. In the sense, otherwise, what a general addition instruction should be? General addition instruction should be add number 1, comma number 2 and result should be the general instruction. But the designers those days were having multiple constraints. So what they have done, they have decided to design add instruction in a restricted manner. Means what was the purpose? That means for a person who is struggling to maybe in COVID pandemic, all other aspirations, whether I will pass or not, were not there. The issue was whether I would be able to successfully survive or not. So like that, for 885, addition should be provided. What once means you should provide one instruction which performs addition. Right? So what the designers have decided? Designers have decided to provide add instruction by the restricted operands. That is, accumulator or register A is a default source. Default source 1 as well as default destination. Would you like to correct? So if you are very much curious, attentive, I have deliberately put one incompleteness there. So what will you correct? Accumulator A is a default source 1 and default destination. I want you to correct something. Default source 1 as well as, so that as well as default destination. There is incompleteness in the statement. What is that? Destination?
Part of.
Right. Default destination for 8 least significant ones. Is it clear? Because addition is not 8 bit, it's 9 bit. So accumulator is a default source 1 as well as destination for 8 elements. Then R is source 2. And there is one more register we have shown in the architecture. Flag register. In flag register there are bits. In flag register there are bits. 8 bits. Of them 5 bits are defined. So that flag register contains a carry flag. So carry flag is destination for 9. Is it right? Carry flag is destination for 9. Is it right? So add instruction for 885 works as carry flag and A getting assigned to A plus R, and this is given by the instruction add R. It how many byte instruction? Add R. किती बाईट असायला पाहिजे? बाईट किती? 1 byte. How many such instructions? किती असतील instruction? 8. R is 0 0 0 1 1 1. A, add B, add C, add D, add E, add H, add L, and add M also. Right? So 8 add instructions where accumulator is getting assigned to accumulator plus register R, and the 9th bit, that is the most significant bit of the addition, that is the carry out, puts it in carry. Is it right? So add R, add R. There is one more instruction, means add R is there somewhere. The instruction set of 85 has some flexibility. It's not that it's completely inflexible. Some flexibility. So sometimes when you want to add some known number, there is no need that you should take it somewhere. So one more facility they have provided, that is, आता मी हे करतो, थोडंफार आपलं पुढे जायचंय. मी इन्स्टंट लिहितो, मिनिंग मी सांगत नाही. आय वुड लाईक टू गेस मिनिंग फ्रॉम यू. आणि फुल फॉर्म पण मी फक्त मेमो ADI डेटा E. किती बाईटचं इन्स्ट्रक्शन आहे? 2 byte. Why? It is add image. याचं एक सही डिस्क्रिप्शन सही. What will be getting assigned to what? हे होतं तसं इथं काय येईल? काय येईल? उजवीकडे काय आणि पुढे काय? ADI add immediately what? 8-bit data in what? A is one of the default operands. So A plus and result carry flag and accumulate. How many byte instruction? 2 bytes. How many machines are going to be required? How many machines are going to be required? 2 or 3? AD किती बाईटचे आहे? 2 bytes. So minimum 2. Whether execution of instruction will require bringing something from memory, it is there. It is brought in the second byte of the second machine cycle of the instruction itself. Whether additional reference will be needed or not. Okay. See, I will repeat till you understand. So we take an example, and in that example you may, let's hope that you will understand. We take fresh example. At 0 0 0 0 we take MVIA 04 at 0 0 0 2 add immediately 02 at 0 0 0 4 STA 5000. मी तुम्हाला स्टेज पुन्हा रिव्हिजन ज्यांना कळेल तर पुन्हा रिव्हिजन मिळते. ॲट 0 मेमरीमध्ये काय असणार? ॲट 0 0 0 0 3E 04 at 0 0 0 2 add immediate C6. We will just confirm. I'm not so sure. Of course, ठीक आहे, पाठ करायची गरज नाही. मला पाठ ते पाठ करू नका. किती असणार 0005 ला किती 0 आणि 06 ला 5. Now we start. पहिला type, address. Now you said that you need a question bank. So I announce the question bank publicly. For the question bank is for all instructions. Type, address, data. सर्व instruction 946 instructionला ते लिहायचं. That is question bank. Type कुठला पहिल्यांदा? Fetch. Program counter giving 0000. किती आहे? 3E. Where it will go? Again I repeat. When it reads the instruction 3E, it comes to know that it is how many byte instruction? Move immediately to accumulator. किती byte चे? 2 byte instruction. So next machine cycle with program counter as address. So when PC is used, PC will be implemented. It is instruction read, I can say. Program counter giving 0001. What is there? 02. Where 02 will go? Where 02 will go? Listen, now don't answer. Listen, those who are not understood, for them I repeat. In the first machine cycle, 8085 has read the instruction or read the combination 3E. 3E happens to be the instruction opcode for the instruction move immediately to accumulator. Move immediately to accumulator is a 2 byte instruction with the second byte to be taken to accumulator. So immediately after the first machine cycle, micros comes to that I have to undergo a second machine cycle, which should be a memory read cycle obviously, or instruction read cycle, and the value which I obtain should go to accumulator. So 0 will go to sorry, not 02, 04. Go to accumulator. Then now what was the instruction? Moving 04 to accumulator. It has gone there. So instruction is completed. So in the second machine cycle, it is 2 byte instruction. It is over in 2 machine cycles. Right? Now when it is over, next will start. And now the further question bank is only number of bytes and number of machine cycles for all instructions. This is detailed question bank for detailed questions, and this is question bank for objective questions. MCQ नाही, objective. कारण MCQ विषयच नाही, 1 2 किंवा 3च आहे. There is no question. काही केलं 5 आहे, 1 2 3 4 5 आहे. MCQ द्यायची गरज नाही, ऑप्शन द्यायची गरज नाही. So 1 byte, 2 byte, 3 byte म्हणजे नंबर ऑफ बाईट किती 1 2 3 आणि नंबर ऑफ मशीन सायकल किती 1 2 3 4 5. Is right. So next what will happen? What should happen? Opcode fetch. From where? Program counter giving 0002. What is that? C6. ते लगेच सांगण्यात काय फार नाही आहे. अगदी सोपं आहे, लगेच मोठ्याने सांगायचं शाळेतल्यासारखं तसं नको. Where C6 will go? Instruction register. Now what is C6? Opcode for add immediately. So it's 2 byte instruction. So next byte is required to be read and which is to be added into accumulator. So instruction read, program counter giving 0003 02. Where this will go? 02. Where 02 will go? Where 02 will go? Listen, I will give. आता ह्याच्यापेक्षा सोपं एक्झाम्पल कुठेही अगदी सोपं एक्झाम्पल देतो तुम्हाला. There is a buffet system. आणि लाडू ठेवलेले. मग आता पर्पज आपण लाडू खायचा आहे. मग यू गो, मग तुम्ही गेला तर काय करता? लाडू खायचा आहे. मग लाडू कसा खाता तुम्ही? असाच घेता का? लाडू हातात घ्यायचा आणि मग तो खायचा. आता ह्याच्यापेक्षा म्हणजे एडिया इन्स्ट्रक्शनला हे जे 02 आहे ते कशा करताय? ऍड करण्याकरताय. म्हणजे तिथलं तिथं होतं का? लाडू कशा करताय? खाण्याकरताय. मग तो तोंडाने घेतो का? आपण हाताने घेतो. मग 02 काय झालं पाहिजे? इट शुड गो टू Z, temporary resistance Z. And now listen very carefully. At the end of second machine cycle, microprocessor has read the instruction completely and it is fully equipped with all necessary operands for the instruction. Accumulator is there and immediate value, that is Z, is available in Z. But addition is to be done. Then can that happen internally? Yes. A is inside, Z is inside. So I can write in bracket here. So it does not require now an additional memory cycle. लक्षात का? Additional machine cycle is not needed. म्हणून मी इथंच ह्याच्या पुढे लिहू शकतो कंसात. ह्याच्या पुढे कंसात म्हणजे काय? हे 02 has gone in Z. त्यानंतर ऍडिशन होते पण ती इंटरनल होते म्हणून ती कंसात लिहिली आहे. इट डझंट रिक्वायर ए सेपरेट सायकल. सो हियर व्हॉट हॅपन्स इज कॅरी फ्लॅग अँड ए गेटिंग असाइन टू ए प्लस काय? ए प्लस झेड. ए प्लस राइट. अँड देन नाउ फेच प्रोग्राम काउंटर गिविंग 0004 32 going into instruction register. पुढे 32 happens to be the opcode for 32 happens to be the opcode for STA. So first of all it is 3 byte instruction. So next two things are fixed. Instruction read, program counter giving 0005 0006 0050. Where 00 should go? ST. I again repeat. Last time झालं पुन्हा ऐकायचं परत. Store STA is an instruction store accumulator at. It is addressing mode for source is register. That is accumulator is there. And addressing mode for destination is direct. Means store accumulator in the external memory, the address for which is directly specified as a part of instruction in next 2 bytes with lower byte first and then higher byte. So what is 00? 00 being read in the second machine cycle of STA instruction happens to be the lower byte of the address where accumulator is to be stored later on. So 00 should go to Z immediately. What is 50? In the third machine cycle, the microprocessor is reading an 8-bit value which happens to be the higher byte where accumulator will be stored later. So it goes to W. Then at the end of the third machine cycle, microprocessor has read the instruction STA 5000 completely. It needs to be executed. Since the destination is outside, it needs an additional cycle for mere execution. म्हणजे रीडिंगच्या सायकल लागतातच. जर ऑपरँड बाहेर असेल तर एक एक्स्ट्रा लागतो. सो अँड हियर डेस्टिनेशन आउटसाइड, सो इट शुड बी राइट सायकल. इट्स अ राइट सायकल. WZ गिविंग 5000 and A giving किती 06, right? And add झाले. Is it okay? All right. I think there shouldn't be any problem now. Is it okay? Now next. of this now, I think there is no need to write down this, this and this. It is right. So after these three instructions, what are the status of contents of different registers? Accumulator
0 3
0 3 H.
HFA 5000
5,000.
Okay, so थोड़ा सा जल्दी आता ठीक है. HL 5000 right? 5000. Now the instruction add M. The opcode is 87. Sorry, 80. जस्ट ऑफकोर्स तुम्ही ऑफकोर्स चुकीच नाही. आता नाही तुमचं कसं आहे, तुम्ही लहान असल्यामुळं कंप्लेंट्सला काही सांगता येत नाही. त्याने सरांनी ऑफकोर्स चुकीच सांगितलं अशी कंप्लेंट करू नका. बहुतेक 86 आहे. यू कॅन कन्फर्म 86. नाव व्हॉट इज टाईप. आपण इथं डायरेक्ट आता आणि आता ह्या सायकल सोडल्यात का म्हणू नका. हे तेच वेळ घालायला नकोय. नाव टाईप ॲड्रेस डेटा ऑफकोड फेच प्रोग्राम काउंटर गिव्हिंग किती असेल. किती 0006 86 going to instruction register. Now listen very carefully. It is how many byte instruction? 1 byte. It is 1 byte instruction. Add M. But what it intends to, accumulator is to be added with the contents of the external memory location whose address is given by HL pair, and the result is to be stored in accumulator and carry flag. So at the end of this first machine cycle of add M, micros has completely read the instruction add M. म्हणजे instruction काय ही पूर्ण वाचून झालेली आहे, पूर्ण कळलेली आहे. However, the instruction execution requires addition of contents of accumulator at that location. So that must be brought in first. So the instruction will require additional machine cycle for execution. So add M, number of bytes 1, number of machine cycles 2. Right? Number of bytes 1, number of machine cycles 2. Now next week we will take a specific test for all the instructions covered. Number of bytes, number of machine cycles, or and especially number of machine cycles, read or write. So, and once that I will take very specifically, and based on that, if there is some kind of lagging, then there will be a forced revision for only that group. So at the end of next week, सर्व instructions प्रत्येक number of bytes, number of machine ते आलं म्हणजे सगळे यायलाच पाहिजे. And again, who gives address, data goes where, or who gives data. So a detailed chart of all instructions आलाच पाहिजे. So now what will happen? Next is an execution cycle. So not instruction read, we can say operand read, opcode fetch, instruction read, operand read and write. 4 types of cycles आहेत. 3 read आहेत actually. म्हणजे fetch, IR and OR are read cycles, but the purpose is different. So that we should know clearly, and write is only single. So operand fetch. So for F and IR, who gives the address? For F and IR, always program counter gives the address. Whereas for OR and W, some different register pair gives the address. Normally it is WZ or HL. So now who will give the address? HL gives the address. What is that? 5000. There, let us assume that 04 is there. So 04 will come on data bus. Then what should happen? Where this 04 should go? It should go to Z. It is not added directly. So just we have to take the do by hand and then eat. So it goes 04 should go to Z, and then into bracket carry flag and A getting assigned to. Is it right? Is it okay? I think there is no issue now. right? Now STA, I think there is no need of repetition. So add M is very clear. So with this now, we again discuss. When I say again, it has already been discussed, which you might have forgotten. I write the problem statement. If those who are still able to understand, still able to recollect that, should write, and I will explain. So I write the statement. आणि आता आता इंजिनिअरिंग कॉलेजमध्ये रेकॉर्डिंग आहे म्हणून वहीत काहीच नोट्स लिहायचं असतं, वर्गात लिहायचं असतं, शाळा नव्हे ही. राईट ए प्रोग्राम add two 8-bit numbers stored at 8000 500 and 8051 and store the result at 8052 and 53. H लिहित नाही, we assume that is always hex. Now the important question, addition of two 8-bit numbers is 9-bit number, but in the memory each byte is of each location of 8 bits. So even though it is 9-bit number, we require how many bytes to be stored? 2 bytes, right? It will require 2 bytes to be stored. लक्षात आलं का? म्हणजे दोन 8-bit नंबरची ऍडिशन ही 9-bit नंबर असते, पण मेमरी स्टोअर करायकरता 2 बाईट लागतात. So how will you do this? If carry comes, the logic is simple. If numbers are smaller, then the result would be in 8 bits only. And if numbers are bigger, we may get carry. So, lower byte, byte 1, byte 2, first number, second number, their addition, least a single byte will be addition, and 5, 3 should be either 0 or 1. Is it clear? So E means there is simple logic. What I will do, load. So we start developing, and we start on 0, no problem. So first is किंवा आता हे जी काही गरज असते असला भाग नाही, हे आपण नंतर देऊया. So we start with LDA 8050. LDA 8050. Then move. आता हे आपोआप काय पाहिजे, हे असं आहे की म्हणजे हा काही मोठा ह्याचा प्राईम नंबरचा प्रोग्राम आहे की तो कसा डेव्हलप करायला सांगायला पाहिजे. बरोबर आहे. LDA 8050 move B, A, LDA 8051 add B, STA 8052. If numbers are smaller, म्हणजे आता अगदी पहिलीमध्ये काय असतं, ऍडिशन कशी शिकवतात, 3 अधिक 2 बरोबर 5, 4 अधिक 3 बरोबर 7, म्हणजे 10 हा विषय आला नसतो अजून. So if we are at a smaller level, program, if I modify the problem statement, write a program to add 20 numbers stored at 805051 and store the result of addition at 8052. इथे अजून काय आहे, आपलं एक लहान आहे. So that is the program is over. But now that is not always enough. So we should think of carry. So now what is required? So this will remain common. This will remain common. So flags carry flag and zero flag. Right now only we matter two flags. Right now carry. Carry flag is modified by an arithmetic or logic instruction. Data transfer instruction don't affect the flag. म्हणजे आधी जो असतो तोच राहतो, बदलत नाही. पण add, sub, or या instruction flag change करतात depending upon the result of the operation. So after add B, if carry flag is 0, 0, 0 is to be stored at 805. And if carry flag is 1, 0, 1 is to be stored at 805. So what I do, I proceed by a simple logic of presumption. So I presume that carry will not come. I presume that carry will not come. So what I do, MVIA 00 and STA 805. Carry and right. Now this first number I have taken. Sorry, I made small mistake. 805. 3, right? Then first number taken here, addition done, list LSB stored. Now up to this everything is okay. What is to be done now? If carry is not there, my program is finished. But if carry is there, I have to store 1 at 805. Now that requires me to introduce another instruction for 885. That is, what instruction? Branch instruction. Branch. And in branch instruction there is jump instruction. Number 1. The jump. Right? So we defer this and study jump instruction first. So branch 8 for 8085 jump instruction. Jump, the mnemonic is jump address 16. Jump address 16. The instruction is jump address 16. Opcode is C3. Opcode for jump is C3. Then lower byte and then higher byte. So jump is 3 byte instruction. Jump is 3 byte instruction, and its effect is that after this instruction gets executed, the program counter, which was every time auto incrementing, that auto incrementing or sequential proceeding of program counter is changed, and after the instruction, irrespective of the current value of the program counter, this value which you have put in the instruction gets loaded in the program counter. So suppose if at 0000 I have got jump 5000. So what will be there at 0000? C3 at 0001 क्या असेल? 0002 काय असेल? 1 ला काय असेल? 00 आणि 2 ला 5. टाइप पहिला काय? Opcode fetch. Address काय? Program counter giving. And data काय? C3 going where? So it comes to know that it is how many byte instruction? 3 byte instruction. So instruction read, program counter giving 0001, instruction reading, program counter giving 000. इथे देणार 00, इथे देणार 50. What is 00? 00 is the lower address where it has to branch. So 00 is lower byte of the new address with which the program count is to be initialized later. Later म्हणजे किती? हे झाल्यावर. So 00 available now, required when? Later. So what should happen? It should go to where? Z register. This should go to W register. And what should happen? Program counter getting assigned to, it happens internally. So that is over. So next is opcode fetch. Program counter giving kiti 5000. Is it clear? Is it all right? Program counter giving 5000 and opcode will fetch from that. So it will branch. This is unconditional branch. This is unconditional branch. Now there is one more. Unconditional branch normally in only few cases this is required, not otherwise. But just like unconditional branch, the designers have provided conditional branch. हे असेल तर इकडे नाही तर सरळ. So that is jump on some condition. That condition is either zero flag is set or zero flag is not set. Either carry flag is set or carry flag is not set. Either sign flag is set or sign flag is not set. Either parity flag is set or not set. So there are different options. There are 8 conditional branch instructions. Right now we study two conditional branch. Jump on carry and jump on no carry. Jump on no carry म्हणजे काय? जॉब कोड C2. जर कॅरी फ्लॅग सेट नसेल तर जम्प आणि सेट असेल तर नेक्स्ट इन्स्ट्रक्शन. लक्षात आहे का? जम्प ऑन नो कॅरी. इफ कॅरी फ्लॅग इज रिसेट, it will branch to the address given in the jump instruction, that jump on no carry instruction. And if carry flag is 1, it will not jump, means it will continue. It will continue. Is it right? So now what can I do? After this, can you complete the program? STA 8052. So up to this is okay. Now what I have to do? If carry is not there, everything is finished. And if carry is there, I have to make some change. So what I will do, I will write here an instruction, jump on no carry skip. Labels I am giving, they have some meaning. Skip. म्हणजे कॅरी नसेल तर पुढे जाईल आणि कॅरी असेल तर काय केलं पाहिजे मला? I have to store 1 at 8053. So MVIA 01 STA 8053 and skip is here. ते लगेच करते. Halt. Is it right? Is it okay? Jump on no carry skip. So if carry is there, if carry is not there, what I means I had assumed something. What I assumed? Carry will not come. So I have put 0, means what is the destination location which would be dependent on carry flag? This is not dependent on carry flag. It is directly dependent on addition lower pipe. The 8053 memory location is dependent on carry flag. So I had dependent means what? It's a very primitive. म्हणजे आपण अगदी आता फक्त मिडल स्कूल स्कॉलरशिपला आलोय. डिपेंड म्हणजे फार नाही. कॅरी असला कॅरी नसला 00, कॅरी असला 01. So if carry is not there, 8053 should be 00. If carry is there, 8053 should be 01. So what I have done, I had assumed something. If my assumption is correct, my job is finished. And if my assumption is wrong, I have to correct my assumption. So I say jump on no carry, means if my assumption is correct, this is not needed, it skips here. And if my assumption goes wrong, it comes here, does this, comes here. Now you may say, why you assume that carry will not come? I want to assume carry will come. So what will you do? In that case, you will put this as 01 and store 01 first. And this jump on no carry you will change by jump on carry, and this 0 will be changed by. Is it right? So either way you can go. Is it okay? So it is complete. Yes or no? I think now म्हणजे आता कुठले आणि आता जर हे म्हणजे आता जर कळत नसेल तर तुम्हाला एक असते म्हणजे हे असतं नाही, चीनमध्ये किंवा रशियामध्ये जर का मुलं अभ्यास करत नसतील तर असं छळ कोंडून घालतात. रशिया किंवा चीनमध्ये अभ्यास करत नसतील, आता हे सांगून जर कळत नसेल तर शनिवारी रविवारी 8 वाजता आणायचं आणि कळे परत सोडायचं नाही बाहेर असं करायला. आय थिंक आय होप इट इज व्हेरी सिम्पल नाव, राईट. सो विथ दिस नाव we do next program which again we have discussed. Right, I think she has got understood the program by telepathy. Add two 16-bit numbers stored at 8050 and 51. आणि जेव्हा स्टोरिंग मध्ये कायम सिक्वेन्स आहे, आधी LSB मग MSB, 00 ला LSB, 01 ला MSB and 8052 and 53 to stop. तो रिझल्ट कुठे स्टोर लागेल? स्टोर द रिझल्ट ॲट at 8054 55. The result of 216-bit number is 17-bit number and you have to provide for 3 byte locations. So now how will you proceed? So how to proceed?
First addition of lower bytes.
Right. So now again this is not that we are discussing for the first time. We are discussing for the second time. So we should not waste unnecessary time. We should introduce one more instruction, that is